Alright, so today I'm going to be talking about ambistomatid salamanders and some breeding migrations that they have at the Eagle Marsh Nature Preserve. Okay, so before I get into the nitty-gritty, I'm going to take a few steps back because the concept can get really confusing. And so we have two forms of sex, mainly we have asexual reproduction and sexual reproduction. Okay, with asexual reproduction, you have genetically identical offspring and one parent. So in the simple diagram I have at the top, you can see that you have one cell, maybe like a bacteria, and then it splits into two, and they're identical, right? So with sexual reproduction, you have genetically different offspring, and it requires two parents, okay? So in the simple diagram, you can see that, you might have genes from a blue circle and genes from a yellow circle combined in various ways, and then you get, a different offspring. All right, so some vertebrates that use asexual reproduction are whip-tailed lizards. So there's a picture at the top that shows what they look like. And then also armadillos, sharks, and snakes use asexual reproduction as well. And even some fish, such as mollies, pictured on the bottom. Okay, and then the parthenogenesis, the diagram on the right kind of shows what's happening genetic-wise. So you have the parent, which might have a set of chromosomes A, B, and then you have the egg with the same chromosome set, and then the offspring are identical. Okay, so that might seem pretty straightforward, but sexual reproduction can get really complicated, and I call it bizarre, and I'll get to that in a minute. Okay. So ambistoma salamanders are sexually reproducing species. So we have ambistoma texanum pictured on the upper left, so they're kind of black, and they look similar to the unisexual ambistoma, which are pictured on the bottom. And then the ambistoma tigrinum are, much different. They have like a yellow pattern on them, so they're, very easily distinguishable. Okay, so unisexuals are a group within a species that are composed of only one sex, so in this case females, and they reproduce by stealing sperm from other species. So that might seem, kind of weird, like how can that happen? But I have some diagrams coming up that'll explain that. So the process for stealing sperm is called kleptogenesis, okay? So the unisexuals steal spermatophores from texanum salamanders, and they often do that with tiger salamanders and Jefferson salamanders at other locations. However, at my study site, they only do it with texanum. So spermatophores are jelly-like blobs that contain sperm. So the picture on the bottom right kind of shows what that looks like. Okay, so more on kleptogenesis. Sperm chromosomes may fertilize with the female egg, and you have, or you could have like a replacement of an existing chromosome, or you could simply activate cell division with the sperm present. Okay, so the ploidy levels, which ploidy refers to the number of sets of chromosomes in the species, can increase, remain the same, or as I mentioned, certain chromosomes can get replaced. So this diagram demonstrates all that. So on the left we have gynogenesis, which if you have the maternal chromosomes defined as AB, the sperm comes, activates cell division, and the genome from the sperm is not incorporated into the egg, so the egg just remains as AB, okay? So that's gynogenesis. And then with polyploidization, the maternal chromosomes may be defined as AB, and then the paternal chromosome, denoted as M, may get incorporated into the genome, so you increase the ploidy levels, okay? So go from 2 chromosomes to 3. And then in kleptogenesis, sometimes you can get the replacement of a chromosome. So if you have the maternal chromosome defined as ABB with the egg with the same setup, and then when the sperm comes along, the chromosome from the sperm incorporates into the egg, and then a chromosome from the egg gets replaced. So it leaves, and then you have a new genetically different offspring compared to the maternal chromosome. Okay, so unisexuals must steal sperm successfully to gain genetic diversity. And, it might be like, you might wonder why they would care to do that. Well, genetic diversity can aid in species persistence because when you have diversity, it helps with natural selection, because you could have, say hypothetically, if a salamander has genes that resist drought, and then if you have a drought, then the salamanders with that set of genes will be able to survive through the drought, and then they can therefore persist. So that's why genetic diversity is important, because if you don't have that diversity, then selective pressures can maybe wipe out the entire population, or a lot of it. So there's two important observations to consider with the Texanum salamanders, which, as I mentioned before, are used as the a sexual counterpart to the unisexuals. So the Texanum usually arrive to breed before the females, and that may not necessarily be true in every circumstance, but it has been observed in the past multiple times, and it's disputed currently. I can demonstrate that trend later. And then male Texanum prefer to mate with other female Texanum over unisexuals. So what that means is if a male Texanum has the choice between a female Texanum, so the same species, or the unisexual, they generally go for the Texanum, okay? So they're kind of picky like that. So with a general breeding pattern, salamanders migrate to the wetlands to breed between the months of February and June usually, depending on the weather. And males generally arrive to the wetland first. And Texanum are also known as smallmouth salamanders. They have low sexual selection and mate preference. So if they are confronted with two different Texanum females, then the male, won't necessarily pick one over the other. They're both equally likely to mate. And then there's also, as I mentioned, preference for mating with their own species. So they would rather have Texanum rather than unisexuals. And then the Tigernum are also known as tiger salamanders. Okay, so here's an example of an egg mass that has been fertilized, and you have developing larvae. They look like little lines in there, and they grow and start swimming around when they're more mature. Okay, so how can unisexuals successfully steal sperm if they're not a preferred mate choice? Because that would be, a problem that, if they need that genetic diversity and they can't, if they're not, preferred, then, they need some sort of advantage. So I hypothesize that the Texanum, they have like a certain breeding migration I talked about where the males arrive first and then the females come second. So I suggest that the unisexuals may take advantage of that by arriving before the females, so that way, maybe the males will see the unisexuals first, and they really don't have a choice, so then they'll just go ahead and mate with the unisexuals. And also hypothesize that the unisexuals may stay in the wetland longer to increase their chance of mating success. So our study site was at Eagle Marsh Nature Preserve, which is just south of Jefferson Point, so on the southern end of Fort Wayne. And we used two wetlands in the forest in the circle there. And the wetlands were pretty large, actually. So 3 drift fences were established, and the traps were checked every morning. So that's a schematic of the trap setup. So you have a drift fence, which is like a a fence that's basically impermeable to the salamanders, and it's about a foot tall. So the salamander, as they migrate through the ground, they hit the fence, run along the fence, and then fall into a bucket. And so that's an example of a trap, and you have the two buckets on the end here, and then there's more buckets along the fence. So, like the snow probably wouldn't be ideal to migrate in, but that's just kind of how the weather is. It's really funky and makes things more difficult for the salamanders. So this is a schematic demonstrating an important assumption that I had to make in the research. So so I had two wetlands, as I mentioned, one north and one south. They're about 300 or 400 meters apart. And then, so if a salamander is caught on the south side of trap 1, then I assume that the salamander is traveling north. So he would be immigrating into the wetland. And if it was caught on the north side of trap 1, then I assume that the salamander is emigrating from the wetland. So perhaps, maybe he's done breeding and, is returning back to wherever he came from. So after 4 years of sampling, we collected 131 Texanum salamanders, and 36 of those were immigrating females, and then 30 were males. We collected 133 unisexuals, so we caught quite a few immigrating ones. And the tiger salamanders, we caught 39 of males and females. So just to kind of give you an idea of the sample sizes, which kind of impacts the statistics, as I'll talk about later. Okay, so this is a graph illustrating the mean immigration dates of all the species among the years. So we can see that in the year 2013 and 2014, they generally immigrated at a later date, and that's probably because of the weather. There was more snow and colder temperatures, so when that happens, they want to come later because those temperatures are not ideal. And also rain can also affect that. So in 2013 there was a drought, and when there's a drought, dry ground salamanders desiccate pretty quickly, so they prefer to move when there's rain. Okay, so but the average immigration among all the species within the years is pretty similar. So again, that's kind of correlated with weather usually. Okay, so to determine if my hypothesis is supported or not, I looked at the relative immigration dates of salamanders. I did that to control for year because there's differences in the year. As you can see, there are late immigrators in 2013 and 2014, so I wanted to eliminate that variable. So I took the average immigration date of each year among all species, and then I subtracted each individual immigration date from that average to determine if the salamander was arriving relatively early or relatively late. Okay, so in each colored section, the far left is the year 2010, and then 2012, 2013, 2014, left to right. Okay, so in the year 2010, we can see that the male Texanum on the far left arrive on average 5 days earlier than the rest of the population. And then in 2010, for the female Texanum, we see that the females also arrive, or well, not also arrive, they arrive 5 days later than the average. And then in 2010, for the unisexuals, we see that the unisexuals arrive earlier than the females, and kind of early with the male Texanum as well. So that kind of shows some support for my hypothesis. And then the tiger salamanders, they kind of arrive at the same time, so there's really not too much specialty going on in there. Okay, so in 2012, we see that a male Texanum arrived, 6 or 7 days earlier than the average, and the females also arrive later. Okay, so that's kind of suggests that the pattern of that I mentioned earlier, where males arrive before females, is supported in this case. And then unisexuals arrive earlier than the females as well. And then the tiger salamanders, the males actually arrived earlier than the females, so that pattern also switches with that species. And in 2013, male Texanum arrived early, and then the female Texanum arrived much later. Unisexuals arrived later than normal, but they did still arrive earlier than the Texanum females on average. Okay, and then so 2014 for those two species was the only year that does not follow the pattern that I hypothesized, where the Texanum males arrive early, Texanum females arrive late, and then the unisexuals also arrive late, and on average later. And then the tiger salamanders continue that, inconsistent pattern. So we have, early migrations, late migrations, and sometimes males arrive first, and sometimes they don't. So they're kind of inconsistent. So we found that that there was, not much of a difference between years overall by controlling for the year. So the pattern, is somewhat consistent. But our only statistically significant result suggests that the female Texanum arrived to the wetland later than the male Texanum by 9.6 days. So that p-level is 0.01. So that suggests that trend, is occurring. And then the trend I'm looking for with the unisexuals arriving before the Texanum females is not supported statistically with a p-level of 0.27. So while the averages suggest there's a pattern, small sample sizes affects that. So I can't necessarily make that conclusion. And then the tiger salamanders have, on average, no difference between them. And so their patterns are, like I said, they're inconsistent. So, and as far as the emigration dates go, there is differences between years, 2013, 2014, later immigration, probably a result of the later arrival. So, naturally they're going to stay a little longer to mate. And 2010, 2012, same thing, earlier immigration as a result of arriving to the wetland earlier. So I did the same thing for finding the relative emigration dates as I did for the relative immigration dates, where the male Texanum, they in all 4 years, they on average left earlier than the females, so that was consistent across all years. And then the unisexuals showed, much later emigration date on average, but that's probably because in 2013 it was a really weird year. There was a drought and lots of snow at the beginning of the season, so perhaps the salamanders were confused, maybe didn't want to go migrate and breed, so it kind of messes up with the pattern. So our sample size for the unisexuals was pretty high for that year, probably like I said as a result of the weather confound. And then the tiger salamanders, it's really a random pattern, so there's not much consistency with them. So the female or the male Texanum, left the wetland earlier than the unisexuals, and that was our only statistically significant result. And I hypothesized that the unisexuals would stay in the wetland longer than the Texanum species to increase their chance of mating success. So that portion of my hypothesis is, possibly supported, but since there's, the funny year of 2013, it might make that conclusion kind of more, unlikely because, it's like a outlier kind of, where you don't necessarily expect that many to come at that time, and then it really skews the data. So my conclusions on immigration. So in regards to my hypothesis, the unisexuals arrived earlier than the Texanum by 4.9 days. But since that's not supported statistically, that we're going to need more research to verify if that pattern is there or not, because my means suggest that it could be. So I would definitely like to see future research elaborate on that and see if we can figure out what's going on. And then the male Texana migrate 9.6 days earlier than females. And since that trend's disputed among scientists, I was happy to see that there might be some support for that type of migration pattern. And then the unisexuals do not appear to mate with the tiger salamanders. We never found any unisexuals with any sort of hybridization with the tiger salamanders. Their mating pattern doesn't really have any special interaction with the tiger salamanders, so there's not much difference between the means. And then the unisexuals stay longer than the Texanum males by 12.7 days, and that's supported statistically. But like I said, that's attributed most likely to the 2013 data. And then the unisexuals show little difference compared to the Texanum females, so they generally arrive or leave the wetland at possibly the same time. So, that they may not necessarily gain or increase their chance of mating success by staying longer, but it could be. They at least stay longer than the males, so they at least maximize their chance of mating with a male, but maybe not competing with the females. So my limitations: small sample sizes was a big issue. Like some years we only caught like 2 immigrating salamanders at some traps, and other years we caught maybe like 10 or 15, which is nicer, but it makes it harder to make conclusions based on that. So we had an inability to surround the wetland with the drift fence because it's a lot of work. The wetlands are several hundred meters in circumference, so so that can make it pretty hard to. Well, like my assumption on the immigration is harder to support because a salamander could be just walking in parallel with the trap and may not necessarily be immigrating, but if it gets caught, then I attribute it as either immigrating or immigrating, so that could skew data. And then the sampling may not have been early enough because salamanders like to migrate as soon as the ground's thawed, so it's kind of a guess on whether or not we should start collecting. It's a lot of work to get out there and check traps on a day-to-day basis. So I had to make sure that you start sampling, well before the salamanders actually want to migrate, to make sure you can catch the earliest migrators. And then, as I mentioned before, the weather confound really, affects the patterns because you have cold temperatures are not favorable. Snow, lack of rain might inhibit migration, and that can really impact their desire to migrate. So I would like to thank my mentor, Dr. Mark Jordan. He's helped me quite a bit on this project, and we've been through a lot together, getting all kinds of data over the years. And I also want to thank my wife, Kimberly, who helps watch the babies and stuff when I make PowerPoints and all that research, and she also helped peer review. And Dr. Timothy Grove, who helped me develop my PowerPoint presentation. He had excellent suggestions. And then all of my basically former classmates that helped gather data in 2014 especially. And my parents for babysitting as well, because they help keep the kids from messing with my laptop. So, are there any questions?
I have a question. So, so based on your research, the unisexual salamanders, are they, since it's so hard for them to go, I assume, is it hard for them to go and steal the sperm so that they can reproduce, I guess, or no?
Well, I'm not sure if there's like much research done on whether or not they want to competitively, you know, just like, you know, force the female texanums away from the males. But, you know, as I hypothesized, you know, they're better off arriving earlier, because since there's that mate preference where the males want to mate with the texanum females, you know, that could be an issue for the unisexuals. However, there has been research shown that as far as the larvae go, the texanum and unisexuals compete at about the same level. So the unisexuals may not have a competitive advantage.
And they produce males and females, or they also produce unisexual?
But the unisexuals?
Yes.
Well, the unisexuals are only female.
They're always only.
Yeah, I guess that there's a very rare instance where you might find a male, but it's like since there's so few and far between, the unisexuals must rely on stealing other sperm.
I'm just asking this out of curiosity, but the texanum and unisexuals, you had a slide way at the beginning showing them, and they look the same to me. Exactly how do you separate these two salamanders? I'm just curious.
Okay, well, there's a few morphological differences between them, and I think that like the snout in the unisexuals is a little bit like flatter. Like that's how I describe it. Well, Dr. Jordan has a good suggestion. What?
Or like flatter like this.
Yeah.
No.
Oh, okay. Yeah. Yeah, but I mean, it's really hard for me to tell difference. I mean, I looked at quite a few, and you know, I'm not very good at it.
Figure out the difference.
Right. Yeah. Dr. Jordan was the main guy for that. Yeah, he you know, does an excellent job at differentiating them. So.
The smallmouths have they're called smallmouths because they have a blunt, kind of short snout. Whereas the unisexuals, Zach said they're flatter. They're longer and kind of dorsoventrally flattened in their snout shape. So they also have slight coloration differences.
Okay.
That you can use.
Yeah, that could be another issue with my data collection, is that, you know, if we categorize them incorrectly, then there's that, you could have some sort of skewment of the data because, you know, just simply labeling them wrong, you know, but, you know, we have good faith that Dr. Jordan, you know, does a great job at organizing them.
This is totally out of curiosity as well. So what triggered you to do this research?
Well, I always told Dr. Jordan that I used to, you know, go looking for salamanders in my backyard when I was a kid. So when I started as a freshman, I heard that he, you know, did the salamander research. So I kind of, you know, said, hey, you know, I would like to get some research experience. Can I join you? And he said, yeah, sure. So we started collecting the data in the following spring. And then he started explaining to me about the unisexual concept. And that was like mind-blowing for me because I had no idea that, you know, a species could steal sperm from another species to reproduce. So that was, you know, really hard for me to wrap my mind around. But yeah, it's really just like a childhood interest that led into me teaming up with Dr. Jordan. Thank you.
Thank you very much, Zach.
All right, thank you.